Hi, in this video, we're going to show you an extension to the Chapter 16 example from the book, where we're looking at an email campaign and trying to uncover the effect of the email on purchases during the campaign. And we're going to do this using a relatively new method to marketing analytics called causal random forests. So first, before we get into that, I encourage you, if you haven't yet, to go to Chapter 16 example and see what we do in that example with regards to propensity score matching and then estimating a Tobit model on the purchase amount data to try to uncover this effect. A link to that video, the Chapter 16 example, is in the description of this page. Once you've seen that video, now we can see how a machine learning based technique, such as causal random forest, might be useful in trying to uncover this treatment effect. So what is a random forest? Well, a random forest is just a technique, a machine learning based technique, which splits the data recursively into smaller samples, trying to split the data in ways to minimize the prediction error of the outcome variable. In this instance, that would be purchase amount, which is what we're trying to uncover. A causal random forest is similar, but it looks to split the data with the intention to uncover the causal treatment effect. In this case, it's going to find small subgroups that look very similar in terms of their matching data, but one part of the subgroup has the treatment, in this case, the email, and the other part of the subgroup doesn't. And we want to see what the difference is in those purchase amounts of those small groups. Now, what this allows us to do, if we build enough of these small little trees, is to uncover what's called heterogeneous treatment effects, or essentially looking at each individual in the data, what was the treatment effect on that person. Now, we're going to aggregate that up to a single value and look at the average treatment effect as determined by this causal random forest to try and figure out if this machine learning based technique also arrives at a good solution for us to uncover the value of this email on driving purchase behavior. So let's start out by rehashing, let's say, what happened in the last example. So in the last example in the chapter, we saw that we did propensity score matching because we felt like people who had given their email addresses might be different from people who did not give us email addresses. We saw that to be the case. We followed that up by taking those matched groups, running a model, in this case, a Tobit regression, where we had purchase amount during the campaign period, which could be 0 or some positive value of purchase. So we ran that Tobit model given the censoring of the data. And then we did predicted values, and we compared the prediction values of the treated group versus the matched control group or the non-treated group. And we saw that the average treatment effect after doing all of that was around $3.60. In fact, let's go to R now, and I've run the code for the last one with that result, and we'll be able to see exactly what the result was from Chapter 16. So we're in R, and what I printed out here in the console window was exactly from the Chapter 16 example, where we looked at the difference in the mean purchase amount across the two groups. We see for the matched non-email group, it was about $19.10. For the email group, it was $22.70, or about $3.60 difference. So we attributed the email to about $3.60 increase in purchase. So now what we're going to do is we're going to look at how a causal random forest would work and see what result this gives us. So the causal random forest is in a specific package in R. So there's a package called GRF, Generalized Random Forest. So first thing we're going to do is we're going to install that package if we have not yet already. So I'm going to go ahead and hit run on install. Now, I've already installed the package, so it's not going to need to do that. But for you, if you haven't installed it, it will come up and it will ask you, do you want to install this package? If so, from where? I often just pick the cloud. but you can pick whichever server you want to install it. Once you've got that, then you can load the library and set the seed. So let's go ahead and do that next. So we've loaded the library for GRF, we've set the seed, and now we can do our analysis. So step one of the analysis is reading in the data. So we had this retail PS match data from chapter 16. So we'll go ahead and run that and find the data. So the retail PS match data. Now, if we want to look at this data, we can type head and then in parentheses data, because that's what we name the table. And we can see here the first 6 rows, we have the same data as in chapter 16 example. We have the customer number, whether they gave you their email, so they would have received the email on the campaign, their purchase amount during the campaign, their revenue, number of orders, the square of number of orders, and the recency since their last purchase before the campaign, all pre-campaign. And these are going to be the X variables we're going to use as matching. Right, so we have the data, same data as chapter 16 example. So here, all we have to do to run this causal random forest, first, we're going to identify the set of X variables that we want to use. One way to do that is just the name of the columns. So I've typed the name of the columns here. That's going to save in a value called X vars, which will then tell the next step that you should load these variables into a table. So here we're going to create in this X variable a data table, which includes the columns that we outlined above here. So those are the same 4 columns that we used for matching in the propensity score matching example. So let's go ahead and load that up. So our X is going to be those 4 columns. Our W variable here represents the variable of the treatment, right? So in this case, that's whether or not we have your email address. So we're going to identify W as the column email by data $email. We're going to identify our outcome of interest here. That's the purchase amount. We're going to do that using data $purchase amount and load that into our Y variable. So now what we have is we have X, we have Y, and we have W, right? Y is our outcome. X is our set of variables that are going to be used as matching variables to split the samples. And W is going to be our treatment variable for the people who received the email or didn't receive it. The next step is to run our causal forest. So there's a function causal forest in the GRF package. We're going to pass it X, Y, and W. And we're going to get the outcome of that into an object called, we're going to call it email.forest. So we'll go ahead and run that. Sometimes this takes a little bit of time to run depending on the speed of your machine, because in the background, what it's doing is it's building, the default is to build, I believe, 2,000 forests. Now it just finished, so this ran relatively quickly. But the default is to build 2,000 of these forests where it's splitting the data into those groups, where each of the smaller groups are going to be similar on their X variables, different on the W variable, or at least they'll look for the difference on the W variable, and then measure that at treatment effect of purchase amount. So next step, we can just take the average treatment effect. So this average treatment effect function, we're just going to pass it the result of our email forest, and we're going to say, tell us what the average treatment effect is. So when we run that, now one thing we do see in the warning section is that in some cases it had trouble matching the data, which isn't surprising given that there might be very big differences between the email group and the not email group. So this warning is sort of saying there were times when it was difficult to find good matches between the groups, in a sense. Which is potentially okay. We could build a lot more trees to try and get around that a little bit. We could also just look at the effect on the treated rather than the entire group, so that we could only find matches for the treated and so on. But that's just a warning for us to know that there were some challenges with matching. Here we see the result, right? So our estimate is our estimated average treatment effect, and our standard error tells you sort of how confident we can be. And as long as the effect is, two standard errors makes it pretty significant. So the standard error is relatively small compared to our estimate, so it is significant. Here, what do we see? Our estimate is 3.51. So what this model just said to us is that using the same data as the Chapter 16 example, building this machine learning based causal random forest, what came out the other side was the average treatment effect of about $3.51. So if you remember back to the top here, this was the result of doing propensity score matching with our Tobit regression model and then predicting the outcomes and comparing the two groups. What we've essentially seen here is the machine learning based causal random forest achieved a very similar result. $3.60 for the propensity score matching Tobit regression, $3.51 for our machine learning based causal random forest. So in the end, we can say that there are other methods out there that might be useful. Here, a causal random forest might be another option for us to consider when we're trying to look at treatment effects and trying to separate out, in this case, who received the email and what did they do relative to people who look similar to them who did not receive the email in the other group, and what was the impact of that email. So this was a video that was meant to show you some of these extensions that are available. The code for this exercise, the link to get it is in the description below if you want to have the code and the data to run this exercise on your own. And hopefully you can see how there are different ways that we can approach the same problem, some using traditional techniques, and in this case, showing you an example of where we can use new machine learning based techniques to arrive at similar results in marketing analytics.